Hi everyone. Today I wanted to show you how you can make an adjustable signal delay circuit. And something like this can be incredibly useful in your builds, especially when you need a really long delay or time something precisely. I was working on the return system for the flying machines on a bamboo farm, and I needed to create a really large delay so that the collection system could catch up. And usually when this sort of thing happens in builds, you can quickly end up with something that looks a little like this. Or this. So to tackle this, I thought I would start with an etho clock. I love this thing. I use this all the time. So it would make sense that I would start here because this is really my go-to whenever I need to time something. But there are a couple of problems to solve. This is a clock. So we need to convert it into something that will run once and ensure that there is a single pulse whenever this redstone block returns back into the starting position. Now the whole thing can be turned on and off just by powering this block here. And once this block is powered, this piston will extend, or it ensures that this piston stays extended. And this redstone block will lock this hopper, keeping the items locked in place. Now, this is what's going to time the whole system. So the more items you add, the longer delay you're going to get. The one thing I noticed is that if I unpower this block, starting the entire clock, but then I lock it right away, you can see that the clock starts, it'll return back to its normal position, and then it stays locked. So it essentially runs once. And then because of that, I noticed that you can also trigger it the same way just by powering it with a torch. I can add a button, and now I can trigger the entire system one time just using a button. Next, we need to get a single pulse once this redstone block returns. Now this part's a little tricky because if we use a redstone line like this, you can see we get a constant signal. And when we activate the clock, it will unpower. And once the clock completes, you can see it powers again. And we really only need this for a short delay. We want to create a single pulse once that block returns. So that's not really going to work. If we use an observer, you can see what happens here is we get a pulse once the clock starts, and then we'll get another pulse once the clock completes. So that's not going to work either. The solution to this problem is actually combining both of those into one and connecting them into an AND gate. Now, the way an AND gate works is that both of these torches need to be powered in order to get a signal out the other end. And the way I like to think about an AND gate is that this torch and that torch needs power in order to generate power out of the other side. But really what's happening here is that once one of these torches is powered, it will power this here, which will power this block and invert this torch here, turning it off. Once both torches are unpowered, it will unpower this redstone here, which will then invert this torch, turning it back on, and then turning on the lamp. And how this connects into the clock is, once this block retracts into this space here, it will turn this line off, turning this back on, keeping this line powered. This will create a signal, just a single pulse, turning this off temporarily. And in that amount of time, one of these will be on, not creating a signal. Then, once the timer completes and the block comes back into the starting position, this line will turn on. This will create a single pulse up through the powered rails, convert back into a pulse with 3-tick delay, ensuring that there is enough time that this block is actually powered long enough for both of them to be powered at the same time. This will invert this torch here, creating a signal to turn on the lamp. So let's give this a go. Perfect. That's exactly what we wanted to happen. And from here, the design can be improved a little bit more by replacing the powered rails with an observer line going into the same repeater with a 3-tick delay. On the other side, we replace the constant redstone signal with a T flip-flop. But the result is still exactly the same. Once we activate the clock, the block is retracted, unpowering this here. Once it completes, it repowers and the lamp lights up. And we can make this design a whole lot smaller by using a dropper to create a monostable circuit. Now the way that works is the dropper will only dispense an item once it receives a signal. It will not dispense an item once it loses it. I have an item in here, and I've added this to represent the top of the clock. I'm just going to trigger it manually to try to show you what's going on. So let's say the clock is activated, it's running for a certain amount of time, and then once it completes, you can see only then the item is dispensed. Now this time I can add a hopper pointing into the dropper just like that. I'll put the item back in, and then I can take a comparator output from the hopper just like that into a redstone lamp. Now this time, once I activate the system, the timer completes, and once it's completed, we get our short pulse at the end, completing the falling edge monostable circuit. Now you can think of this whole process as a very long button press. You press the button on the rising edge, it's running for a certain amount of time, a very long delay, and then once it completes on the falling edge, you get your short pulse. Okay, so now putting everything together into the final build should be pretty simple, and I'll show you how to do that now. First, we want to start with building the clock, and we do that by placing two hoppers down like this pointing into each other, just like that. Then we can take our comparators on pointing out either side into solid blocks with a redstone dot on top. Then we take our sticky pistons aiming for the hitbox, just like that, so that our pistons look like this. Then we can take our redstone block, place it here. Now to activate the clock, I'm going to place a block here with a redstone torch and redstone dot here. This will power this block here, extending this piston, making sure the clock is locked in the starting position. Then I will take a button and place it on top, just like that. Now I can add in the items into the hopper. This will give the entire clock its delay. Now the first part is complete. Now for the second part, I need to add in the monostable circuit. And to do that, I take the dropper and I place it pointing up just like that into a hopper. Now I can take my slabs out just like that and place a comparator coming out of the hopper just like this. Now this next part is completely up to you, and it really depends on how this fits into your build, but you can handle the redstone signal coming out of this comparator pretty much any way you want. But for now, I'm just going to add in a repeater and a redstone lamp just like this so we can see what's going on. I will ensure that there is one item into the dropper right here, and we're done. Now we can test it and see how this works. All right, let's give this a shot. Okay, the clock is active, and we have our delay, and once the clock completes, we get our short pulse right at the end. And there you go. Well, that is going to be it for this tutorial. I really hope you enjoyed it, and if you did, please leave a like, and don't forget to subscribe if you have not already, and I'll see you in the next one.